So we come from the University of Chile. Actually, by the way, I'm French, she's Chilean. Nice to meet you. And yeah, so we are from the University of Chile. So where does the profile come from? The profile actually is a commercial mobility with creative, federated, and structural effort. So the thing is, the university is like a sponge. When you have a point that comes in, you don't know really what's going on inside the sponge. So the profile is really structural for efforts. Okay, so we're going to talk about essentially about Roassal. We're going to make a lot of demos, plenty of demos. So we're going to have like different parts of the talk. So feel free just to interrupt and maybe not wait until the end because there are different things I'm going to show you. And yeah. Okay, so this is like a picture we took from the group when Steph was visiting us. So actually there are some more people missing. So we are a nice group. So I'm probably the happiest professor in the world. I'm really surrounded by very smart students. I'm really, really happy. I'm really happy to bring them here. Yeah. So yeah, so we're from Chile. Chile, before me I got to Chile, I didn't know who I was. Full of mountains. Okay, so as I said, there is 4 different parts of the talk. So we have to spend some time on Roassal, which is the visualization engine. So Roassal is about drawing things. Then we use this engine for many different things. So we're going to show you like 3 products that are based on Roassal. So the first one is called Kite, which is code profile. It tells you exactly why and where application is low. Then we have the about test coverage tool, which is about like, the test coverage. And so we have the room, which is about threat monitoring. Okay, so Roassal. So Roassal, is a scriptable visualization engine. So that is that you can write 3-4 lines of code and boom, you can start to draw your object, your domain. And this is interesting. So you can easily build some very interactive graphical representation of some data. So some people might say, oh, before we had Mondrian, so what's the relation between Mondrian and Roassal? So everything that Mondrian does can be done in Roassal. And Roassal will be much more by having some interaction on top of it. Yeah, so now we can move on with the demo.
Okay, so I'm going to show you Roassal in words. So Roassal comes with a tool called the Roassal easel, and it is accessible from the toolbar in VisualWorks, so just click in this icon. The main idea is just to build visualization incrementally. So here in the input space, you can script everything. You just click in Generate View, and you see the result in this visualization area. You don't like it, edit it, and then tweak it until finally you see what you wanted to do. The main thing to do in Roassal is to add nodes. So first of all, I'm going to add just one node for you to see, just a node 1. So if I generate the view, you will see just a small square that I can drag. And if I pass the mouse over, I see a little path indicating the model behind it. Sorry, the domain. So now I'm going to add more nodes. So I'm going to add 20 nodes. And now you can see 20 little squares, each one representing one of the elements of the collection that I give as a parameter. Again, I can move the view, but I also can drag the elements and same as before. So Roassal actually is usually used to visualize code. So what I'm going to do is to visualize the collection hierarchy. So I'm going to add as a parameter all the classes in the hierarchy. So now we have a lot of squares, but each one representing a class. The first is collection. Then we have sequential collection, order collection, etc. Now that I have the boxes, I would like to add relationship between the boxes, and that will be the superclass. So I'm going to add edges that will start from the superclass. So I will give a block as a parameter. Oops. very easy. This is also draggable. I can draw the view, etc. Here we have a little menu in which you can zoom in the visualization, you can zoom out. Maybe you want to find a particular class. For example, I will try to find a string. And when I do it, the class will be in the center of the visualization, and it will blink. So here, this is the string. Another thing that we have worked on is to export visualization. So for example, we have different formats like HTML, PNG, SVG. I can export it to HTML just for you to see. And I have it here. So this export is just for viewing. It doesn't have all the interactions, only the pop-up and the draggable, but it's just for you to maybe have it in your web page. I don't know. So now that I have the arrow key, I would like to add some shape because I just have little squares. It's a bit important. So I'm going to say that the view has a shape, that each class will still be a rectangle, but the width, it will be each class number of variables, and each height will be the number of methods. So I will, yes, everything seems okay. I will generate it, and I will see a much richer visualization. So for example, you can see the collection hierarchy as a collection class that is very tall, which means has a lot of methods, and these other ones that are very short have a lower number of methods. But all the classes seem to be very thin. So I'm going to augment this just a bit to see the difference. Now I can see much better. So the collection hierarchy, the collection class, sorry, has a lot of methods, but doesn't have many variables. But this one, the class loop preference, I can see that has a lot of variables and a relatively larger number of methods. So now I have a shape. I would like to add color. So what I can do is to use a method called linear field color within a domain. In this case, would be the collection hierarchy, the domain. So this method, what it takes is a domain with all its classes, and we'll add inner color according to the block that I pass here. What I can do is actually pass a block, or pass the simple representation. In this case, it will be the number of lines of code. So the idea is that for the classes that has a lot of number of lines of code, it will have a very dark color, and the ones that have fewer lines of code will be more light. Sorry, semicolon. This is because the Linux in Visualworks needs to pass the path for the code. Done. Sorry. So now I have a lot of classes with inner color with different kind of grayscale. I have this story change set, which is very dark, so I can assume it has a lot of lines of code. And this one, who is the to list, doesn't have many lines of code. The coolest thing of Roassal is that it's not just visualization, it's interaction. So you can build interactions and make it as complex as you want. I'm going to add a very simple one. So I'm going to say view interaction, and the action will be browse. So I will give it a symbol or a block called browse. So now if I right click and I browse, I will have a different system browser selecting the collection area. I can do each one in the collection area. The last thing I would like to show you is the nested method. So I'm going to back to the original collection hierarchy. The cool thing is that for each class that is represented, I can add another node. So I'm going to say view nodes for each. I'm going to do something. So each one class, I'm going to add more nodes, and each one will be the method inside the class. So now I have all the classes and all the methods of the class inside. So first I have the order collection, and then inside is the compiled order collection method trim, or the sum. So this is not a very pretty visualization, so I will add a different layouts for the inner node. So I'm going to add a grid layout and generate it again. So now this is much better, so I can see a much representation of the class. So this is sequential collection, and you can see all the methods that has. And that's the very basic of Roassal. So I'm going to review Alex with the presentation.
Yeah, one question for you, so to interrupt, sorry. You showed us the example of exporting it as an HTML.
Yeah.
If I wanted to do something like this in my Seaside application where I wanted to show, for display purposes, just a hierarchy of some data, would that be something that I could easily wire in my VisualWorks Seaside application? Are you familiar with the way of doing that? Like, would I have to write it out as a file and reference it, or can I do something in memory and then render it that way?
Well, the export for now is just an HTML file that has some JavaScript interaction. So.
Okay, so if I could serialize that and just insert,
Yeah.
send it out. Oh,
Yes.
great, excellent. Okay. Thanks.
I mean, it should be really easy to create, CSAT exporter maybe, where you want to provide the JavaScript from different.
Yeah, I could do that as a static part of it.
Basically, the stream, we write in the script. That's really
Nice.
How do I reference my own domain objects? In this example, we're referencing globals or classes and stuff, so you can type it right in there. But if I have my own objects, do I need to assign them to a global first, and then?
No, you just pass it as a parameter. If you have access, just use it.
Okay, makes
I mean,
good access to.
I mean, this is a set of objects, and at some point the script, I mean,
How do you get the objects into the
the way you want. I mean, this script we have shown, I mean, can be within a method, and the method, I can say maybe like a method called visualize. So I send the message visualize to one of the objects, and instead of having few nodes with some objects, you can set for whatever.
Oh, okay.
Yeah, and the thing is that the easel is just to build in there, and as Alex said, you can build your own class and do all the instantiation and build everything by your own. So this is only just to learn it.
So you don't have to use the easel?
No, you don't have to use the easel. This is just for building more easily and more dynamically.
If you set visualize to collection, not a collection, but to class collection, can you show us what happened?
Yes, not yet, but not now. Yeah, we have some extra fancy demos. So we have to talk about that. Yeah, so we've been working on Roassal for a couple of years already, and we have really we have many users, especially from the Power community. So there is all the news community which is using the tools, and yeah. So it works. So Roassal works with Cairo, both on VisualWorks and on Faro. So Cairo can be used, and it's very nice when you want to do visualizing and some, Bezier complex shapes. And actually I working on JavaScript with Amber, so it works on Amber. Currently we have one engineer working on that. Actually I've been working on, so Roassal works on 7.4. This is necessary for to meet one requirement from our sponsor. And so he works on 7.10, and Roassal also works on PS Smalltalk. So yeah, we won't do the demonstration on PS Smalltalk, but then offline my laptop, then something I can show. Something we're currently working with John and his team. And yeah, so and the best thing maybe is that it is under the MIT license, so it's free. So you can just download it, install it. On VisualWorks, since it is on the SIMCOM public store, just look for Roassal, it's free. And yeah, any question on Roassal from one?
I tried to use Mondrian some years ago, and I found it very hard to get into it. So is there some kind of documentation, what kind of methods you can send to these objects that you created in this easel panel there?
Okay, so
there it looks all very simple, but then you know all the methods that you can use.
okay, so there are different things. So I was one of the author of, I mean, I am one of the author of Mondrian. And you know, I had to deal with some legacy code and next Mondrian was really not well designed. And it was complex. And the thing is that you have a lot of different concepts that are mixed. In Roassal, the code is really clean. And really, I mean, we are really proud of Roassal. The code is really, really clean. The methods are very short, and it's really easy to extend it. So basically, so you have Roassal, which is the lowest API, and then you have Mondrian on top of it. If you don't like Mondrian, you can just use the lower level, which is easy to use. But the documentation, yes, we have plenty of documentation. So there is tons of examples that are shipped with Roassal. We are currently writing a book on that. So we have a couple of chapters already. If anyone wants to give feedback on those chapters, I'm very happy. Okay, so now we're going to talk about Kai. Kai is a code execution profiler. Basically, use the video. So, Smalltalk, all the Smalltalk basically have the same code profiler that looks like message tally or AT profilers. You profile your thing and you have a tree, text to a tree usually. And so we believe that this is really a weak point of Smalltalk implementation. I mean, you profile your application written with classes in object pretty much the same way that you profile your application in C, which is probably a good indicator that something is wrong. So we've been working on the code profiler, and it gives you an answer such as, is there a slow function which is called too often? This is a simple question, but it's very hard to answer. Now, thanks with Kai, you can have a look at that.
So I'm going to show you a bit of Kai. Kai is also available available from the toolbar with this little icon here. It provides a very simple UI. And you just need to give two things. First of all, the expression profile. So I'm going to use one that it comes in the help information. Just a copy. And then the number of iterations. The number of iterations means the number of samples in the end. So the larger number of iteration, you will have more information because the profiler will do more sampling. For this case, I'm just going to put training. I'm going to profile, and I will have visualization here. So this is similar from the demo I did. First of all, we have some legends. So we have the total execution time, the number of classes. Then you have a little metric we use to say if the number of iteration was okay or not. In this case, an increase of number of iteration is recommended. Then you have information about the sampling profiler, and then you have information about the visualization itself. So, the legend, yes. Sorry. So the visualization is very similar to the one I showed in the demo of Roassal. The idea is to have a class, which is this big square, and inside each class you have all the methods. So here you have all these square methods that are executed, and this one in gray are methods that are not executed at all and are not related by a call to any other method. So, first of all, if I put the mouse over, maybe another because of the resolution, you will see some information. First of all, the number of the method, which is in this case is shape. It will also tell you how many times it has been executed. In this time, like 20,000 or so. You will see information about the local execution time, the total execution time, and then you will have the code of the method. So now we can see some things, because in this case we have two important metrics. One is the length of a method. So if you see this long method, it means that this takes a lot of time to execute. This one marked in cyan are the ones that are in your expression to profile. So in this case we have the edges from, and you can see it is here. Sometimes the profiler cannot gather all the methods here, but it depends on the number of iterations that I said before. So another important thing is the number of executions. So as you can see, this one has been executed just one time, so it's a very thin method. But this one right here has been executed like 100 times, so it's very, very weak. As I said before, you also have this menu here. You can zoom in, so out. You can find a class. You can find methods, so just like that. And as I said before, we have interaction, and you can make them as complex as you want. So, for example, I would like to view all outgoing methods from this one related by these edges here. So I just can click, and I will be another visualization will open, also with the same metrics and some legend here. You can also have information about the time profiler. That is the usual report we see. Well, yeah, that's basically it.
Okay, and yeah, so Kai works on 7.10, 7.4. Okay, so that was for Kai. Any questions?
If you go back to the previous slide, there's a question on there.
Yeah.
Can you show us, how do you identify that slow function that's called too often in your example?
So this big square here is a class, and inside you have the methods. So here you see that the methods have different shape. You have the A and the width. And so the width is the amount of time you spend in the method. The height is the amount of time you spend in the method. So you spend a lot of time in this method, in this method, in this method. And the width is about the number of time that's being executed. So here, you don't spend that much time, but we spend more time here and here. And this one is executed like many times. So this visualization is a tool for you, for the programmer, to understand what's going on, during the execution.
So when I look at this, these wider, taller boxes is a place where I would want to go look to see are there performance issues perhaps here.
Yeah, exactly.
It may be totally optimized right now, but that's because it's doing all the heavy lifting.
Yeah, exactly.
Okay.
I mean, we have a lot of documentation about that. Also, we have different view that shows you where side effects occurs, and this is really interesting things because then you. I mean, we have different views that show you like where the side effects happen, and this is really interesting because if you have like a very thick method, very wide method that doesn't do a side effect, maybe you want to do, to introduce a cache minimization. So we have plenty of documentation about that.
Okay, thank you.
On our webpage, you can find, case studies for the particular problem. Okay. Okay, so Loom. So Loom is a thread monitor. So, I mean, we always found that before the fact that in all the operating systems, then you have these tools, that show you that whether you run processes in a machine that, takes consume the CPUs. But then it's more when you don't have that. Or at least not in a nice way. So we've been working on Loom. So Loom looks like something like this, where here you have the list of processes that are currently running. And here we have some graphs that show you, which thread is consuming how much of the CPUs. So, and here you have a number of commands. You can terminate the process, you can change the color of a particular process. And yeah, so it's kind of fun. So the thing is, to get this data, to have this result is really not easy. So you really spend a lot of time on that. So behind we have a probabilistic model that tries to estimate what is the consumption of the thread. So the challenge here is not to not modify the VM. So this is that works on plain VM, and we have some statistical data for each thread. So it's available on the STIC Config store under Loom. So you look for Loom. So yeah. So something else I would like to add is that this is not a trivial piece of code. So if you try it and then you have some behavior that you don't expect, then just send us an email and try to see what you can do. So probably the things is like the sample. So by clicking here on sample, you can say what is the sampling interval you want to have. So this really depends a lot on your computer. If you're running your visual works in the virtual VMware image, you may have different results than if you have outside this image. So it's there is a lot of adjustment that has to be done, but we have that. So we're currently working on Loom. So one of the things we like to do is to actually get do some offline analysis. So currently, while the application is running, and it's moving, and we're currently working on an offline version where we not have these things, because drawing these things takes CPUs, and therefore the profile itself has an overhead. So something we're currently working on. Okay, so Aparo is the last product I'm going to show you now. So this is about measuring the coverage of an application. So okay, so we use Roassal to visualize the coverage. Aparo helps you to tell you to answer this question whether your code is well covered or not, and what you should do to improve the test coverage. Which method should you test first in order to increase quickly the coverage. So again, we are using a visualization. So here this is the legend. So as before, big square is a class. So here we have the class C1, which is superclass of C2, because here we believe. And inside the class we have the methods. So the methods, the color of the methods tells you whether the method has been covered or not. So you obtain this graph, this picture, after having run the test. And the red methods are the methods that are not covered, meaning that they are not tested while you were running the test, or when while you were running the test. Here you have some edges that tell you that this method you can call that method here. Actually, that will self-code. In the code of this method here you have said that this method is called B. The shape of the method tells you about the complexity. So if you have a short method, it means that this method here is not complex. By complex, we use the cyclomatic complexity that tells you whether you are using a lot of structural control inside. So in this method, which is told, you mean that there is a lot of if and do and collect, select. Here there is none. And yeah, so in red, those are methods that are not covered. So the other one are covered by the test. This method in gray times, and this one black many, many times. This is the equation.
Okay, so About is available here also with the MOI icon. It gives you an UI which with two lists. First, the lists that are available in the system, so you can select them here. And once you select one, it will be in the package to analyze. I'm going to use a very toy example just for the test that doesn't take too much. And once you have selected them, you just click this view coverage. It's important to notice that the package you select must be the ones that contains a unit test to run and the package containing the classes to profile. So now I'm ready. I'm going to press view coverage, and I'm going to have a similar visualization like Kai with a legend here, information about the classes, the methods, the percent of coverage, and then the legend of the visualization itself. We also have all the facilities of finding a class, finding a particular method. And then if you continue the visualization, first you will have all the unit tests, which are with green border, and inside them we have all the test method also with green border, and then all the classes that were reached in the package I selected. So first of all, as Alexandre said, we have all these methods in red, which means they have not been tested by any method. So this one. Then we have some complex method like this one, who is some gray, but it seems to be much complex than the other ones. For example, this one, which is darker and smaller and seems to be well covered. As you can see, if I pass them as over, I have a more complex kind of pop-up. This is the contour flow of the method. So it will show you the method in the middle and all the tests that call this method, and the method that he calls in the column. For the test method is similarly, but it will show all the methods that are tested by the method. A cool thing to inspect is to focus on methods or classes. And for example, I'm going to select one unit test, I'm going to do focus on it, and I will have all the classes that are somehow reached by this unit test. So I can say that this method here is test these other ones. Which is pretty cool, so you can identify the relationship between unit test and your system. And the same can be done by right-clicking on a class. So you will see which classes, which unit tests are tested by who tested that. So, well, that's basically a very short demo about, so we can see more cool stuff.
Short proposal, use different colors. For colorblind people, red and green and gray is not too confusing. I can just see that there are colors, but it gives me a hard time to find out which color. Use red and blue, for instance. That's easy, but not red and green and gray.
Well, I mean, it's very important. A good point and very important one. So currently, we don't have any colorblind people among, with us.
Yeah.
So, yeah. So we cannot have such feedback. Please, yeah, we like to spend some time on that. This is really important thing. So, what is the time master? Gail, so how much time do we have?
6 minutes.
6 minutes. This is really short. Okay, so now here you have the switcher icons. Those are pretty cool things that I'm working on. So we'll show you like just a small things of what we've been working on. So there is the memory profiling. This is the same kind of visualization that tells you like what are the big methods that takes a lot of memories. Tracking flow of object, evaluation of preferences. Often you have the systems, you modify the systems, and then you want to know, what are the differences. I am slower or faster than the previous version. So we currently have a whole range of tools to answer this question. And yeah, so we're currently working on a 3D version of Roassal. So it's coming, so probably this year we're going to show something which is really, really sexy. So we have 2 engineers working on that, so we are really happy so far. And the third one is coming, hopefully. And yeah, so this one is called Sunburst. Yeah, that will be the demo now. Okay, so here this one is done in flowers. Okay, so to answer the question I was before, so we start with this one. So here we send the message float bar to a collection of numbers. So currently, you know, when we are analyzing data, often we have to analyze, you know, values, set of numbers. So we are currently working on an extension of Roassal that, you know, to draw graphs, mathematical graphs. So here you can just send the message float bar to a collection of numbers, and then you have, you know, this one that comes up. Then we can, you know, you can embed the different. Okay, so to do this kind of curves or histogram, then we need to build a new builder. So we had a kind of domain-specific language to do with that. So here we have an example where we have a new diagram builder. We want to have a vertical bar diagram. And in that case, we consider methods. We take the number of lines of code. So yeah, so here this is like one kind of visualization we showed you before, but inside we have, so each square is a class, and you have this, you know, inheritance string, and inside you have, you know, methods. So here, for example, this is the method add that. So here we can see already add that, arrow by shape, and the 8 is the number of lines of code. So let's do that. Different things about like having some pie, you know, pie chart. So here this is, you know, stuff code to this thing here, where we consider all the method, the number of lines of code of the method, and then we say the radius. And then of course, you know, you can zoom in, zoom out, you know, as expected. Does it make sense to you? Or?
Oh, yeah, so far.
So, okay, so here this is, okay, so this one is a really crazy idea. So, you know, so before I show you some square, and you can have diversity on them. But then labels, you know, when you have large collection, you know, large visualization with a lot of names, it's really hard to see what are the differences between those things. So the names, you know, textually written names are not a good medium to remember, you know, what the things are about. This is why, you know, on desktop we have icons. So we have the name, we have the icon, and then we have the name. So here we've been working on visual ID. So visual ID is also yet another module on top for us to generate an icon automatically. So here we have, you know, some classes, and then we can generate those icons, you know, automatically. So something we're currently working on. You know, we would like to add some colors, and yeah, so automatically generating icons. And then here we have the sunburst. So the sunburst here, and we open this one. So here in the sunburst, we would like, so we start with 1. So 1 here is the white things here. We start with 1, and then we do the exploration. So here we say for each number, if it's below 10, then we want to explore some new numbers. No, we want to explore the numbers by 2 and numbers by 2 plus 1. Okay? Then we have color if the number is odd. Therefore, we're going to use the blue, and we're going to use the gray. And then we want to use some Bezier line to see the interconnection with these of things. So this is an idea that, you know, Chris a couple of weeks ago said, oh, I mean, this visualization is really interesting. Please do something with that. And then, yeah, here comes. So here are another things. So here this one shows the classes, the collection classes. So the collection is at the center, and then we do some exploration of all the subclasses, and if a class, or each version here is a class, as before, each version was a number, and then the version has a subclass that is pink in purple, that is pink in gray. So this is like very effective combination. So in a very compact manner, some hierarchies of data. And any questions? So those are like ongoing product or ongoing topics. So probably we'll get something which is more stable this year.
I know you focus on visualization, but I have to ask, is the sampling and the rendering well separated? Because I work on Gemstone, and I'd love to be able to do test coverage of my server unit tests, do the visualization of it as a visualized client, for example. But I've got to gather the data on the server.
So it's a good question that we didn't really, we were very shallow on the profiling things. So we have a framework called SPI. SPI is a framework where we build some profilers. So you can see like this domain-specific language to create visualization. We have the same thing for profilers, and so we have so we can we cover the things. The profiler is the visualization engine, but you can use one, the other one can generate any kind of HTML or textual description if it's your.
But for his question, if you don't think of it as just profiling, but think of it as I want to generate the data for my visualization in Gemstone, and then have the visualization rendered in VisualWorks in the client. Do you have that kind of separation where I can generate the parameters for my visualization in a database and then pass the information up to VisualWorks and have it rendered there?
Well, I mean, this is something that I would expect you or someone to provide, in the sense that, Mondrian works by using objects. And as soon as you have objects, in the image and content, Roassal, then you can start to display them. So I think at the last issue, this day I sat down and using topos, we were able to generate these views from some classes that were on the server side. So maybe you can have a chat with him. So yes, this is, Roassal is really good for that. Yeah, and the last. Okay, so we show you, another things. We can really customize it. They are easily portable. And so we are actually looking for opportunities to collaborate more to do that. Yeah, so that's the very last slide. So I would like to thank you. Really big thanks to Chris from Lab Research. Without him, we would not have been here today and last year as well. So this is really, big thanks to Chris, also to the installation crew, who is trusting us.
You have
No more questions. Time out. Ask it private.